Evaluate without using a calculator. I have 8 examples here to discuss with you, and we're going to try and find the value or the answer to these problems without using a calculator. And what we do to do that is, whenever we have something written in log form, always try to write it in exponential form, and that way it'll be easy for you to find the answer. Okay, so let's do this one first. Log of 1,000. Let's write this over here. So let's say this is number 1. Number 1. Log of 1,000. Okay? The first thing I'm going to do is I'm going to rewrite this. Okay? Now log of 1,000 is equal to what? I don't know. So I'm going to write x. Okay? Because x is the unknown. X is the unknown. Okay, so now I'm going to rewrite it as an exponential form. So I know when nothing is written as the base of log, I know this base is 10. So I'm going to take the base 10, I'm going to raise it to the x power, and I'm going to equal it to 1,000. So let's do that. 10 to the x power is equal to 1,000. Okay, we're done with the first step. The next step is always try and make the bases equal. So if this base is 10 raised to an x power, I want to write 1,000 as a base 10 also. How do I do that? Well, 10 to the x power is equal to 10 to the third power, because I know 10 to the third power is 1,000. So I've rewritten 1,000 as 10 to the third power. Next thing you notice is when you have equal bases, then your exponents must be equal. Okay, so if 10 to the x is equal to 10 to the third power, that means x has to be 3. Okay, and what does that mean? I go back to the original problem and I say, well, log of 1,000 is equal to 3. Okay, and this answer that we got means that 3 is my exponent. So when I'm calculating a log, what I'm really looking for is the exponent of my exponential function, is the exponent I raise my base to get my argument. Okay? Let's do number 2. This is number 2, log of 1. So let's write that. Log of 1. Again, log of 1 is equal to what? I don't know. I'm going to write an x. Okay, and we're going to raise the base to the x and equal it to the argument. So let's rewrite that. It says base 10 raised to the x power equal to 1. Now, how do I get 1? I can't change 1 and make it a base 10. There's no way I can do that. The same like I did here, that I was able to take 1,000 and write it as a base 10. I can't do that here. 1 doesn't become 10 by magic. Okay, so the other thing I have to think about is, well, anything raised to what power gives you 1? You remember that law? It's an exponent law. Anything raised to what power equals 1? That will be x equals 0. Remember that any number raised to the 0 power will equal 1. So if 10 raised to the x power equals 1, it must be because x is 0. Okay, so we go back to our original problem and we say that log 1 is equal to 0. And remember this comes up a lot. And you just memorize it. Log of 1, anytime you see log of 1, it's going to be equal to 0. Okay, there you have those two problems. Now I'm going to erase these two so I can make room for my other ones. Okay, let's see. Let's do number 3. For number 3, I have that log of square root of 10. Let's write that for number 3. Log square root of 10. What does that equal? It equals x. I don't know what it equals. Let's find out. The first step is rewrite this as an exponential function. So we have base 10, right? When we don't have any number, that's a base 10. So this is 10 raised to the x power is equal to the square root of 10. Now, these bases are almost equal, right? I have a base 10 here and I have a square root of 10 here. So I can rewrite square root of 10 if you remember from our last lesson. 10 to the x power is the same thing as 10 to the 1/2 power. So if I have equal bases, then my exponents must be equal. So x has to be 1/2. So I come back here and I say, well, log of square root of 10 is equal to 1/2. Okay, let's do number 4. Number 4 is log of -3. Log of -3 equals what? X. Okay, so here we're going to be careful too. You're going to learn a property of logs with this example. Let's rewrite this as an exponential function. So I'll have 10 to the x power equals -3. I can't change -3 and make it into a base 10. There's no way I can do that. So let's start analyzing. We're gonna ask ourselves, if 10 to the x power is equal to -3, how in the world can I make 10 raised to any power equal a negative number? That's impossible. 10 raised to the 1 is 10. 10 raised to the second power is 100. 10 raised to the third power is 1,000. 10 raised to the fourth power, 10,000, etc. And the bigger this x, the bigger the number. It's never, never negative. Even if I have a negative x, if I have 10 to the -1 power, that only makes 10 to the -1 power is 1/10. It doesn't make my value negative. It makes it a fraction. So there is no way in the world I can raise a 10 to a power and get a negative result. So arguments in logs are never, never, ever negative. Okay? Remember that. This number can never be negative. If you see a negative argument, don't go through the trouble. You say undefined. Okay? Let's erase again and make room for the other ones. Okay. Let's do this one here. Log, that would be number 5. Whoops. Number 5, log base 3 of 27 equals x. So 3 to the x power equals 27. 3 to the x power equals, I can rewrite 27 as a power, right? I can write 3 to the third power. And now I have equal bases, so the exponents must be equal, x equal 3. There you go. So that means that log base 3 of 27 equals 3. Number 6. Number 6 says log base 2 of 1 equals x. We already know from a previous example we did with this one that log of 1 is equal to what? Who remembers? Remember, anything raised to what power will give you 1? Any base raised to what power will give you 1? It's 0. Let's go through the process though so you can see it. So I raised 2 to the x power and I equal it to the argument. Okay, and let's start analyzing. What number can x be so that this whole thing equals 1? Well, x has to be 0. So log base 2 of 1 is equal to 0. Okay? Let me go down a little bit. I think I can, yes, I can go down a little bit. Now I'm going to do number 7, which is this one. And then number 8, I'm going to work down here. Number 7 says log base 6 of 36 is equal to what? And that what I write as an x. Write it as an exponential function. 6 to the x is equal to 36, and I can rewrite 36 as a base 6 number, 6 to the second power. So x must be 2. That means that log base 6 of 36 equals 2. Here's number 7. And now let's do number 8. down here. Number 8. Number 8 says log base 2 of 1/2 equals what? Well, 2 to the x power is equal to 1/2, and this is a nice one. How do I make 2 into a half? Well, notice 2 to the x power, this 2 is in the numerator, right? And now the 2 is in the denominator. So let's think, how do I get that? How will I get 1/2 from having a 2? X must be what? X must be a negative exponent, and it's -1. Okay, so x must be -1. Here's why. If I raise 2 to the -1 power, that will equal 1/2 to the 1 power, which is 1/2. Remember that law of exponents. Whenever you have a negative exponent and it's in the numerator, you bring it down to the denominator and your exponent will become positive. So that's what we have here. I have a 2 in the numerator. Now it's in the denominator. That means I must have raised this 2 to a negative exponent, which is x equal to -1. Okay, so the log base 2 of 1/2 is equal to -1. And these are your answers. I hope you've understood each one of these exercises. I encourage you to go back, try them on your own, and then check the video, rewind it, and make sure you get the same thing I got. I will see you in the next video with more examples.